Hi there, my name is Dan Forbes. I wanted to make a quick video to walk people through how to do a Forkless runtime upgrade on a Substrate-based blockchain. So I want to keep this video pretty short and to the point. I'm going to assume that people are already mostly familiar with the Substrate framework for building blockchains. I'll talk a little bit about some of the core concepts that are really relevant to this idea of forkless runtime upgrades, and then I'm going to run through the process of doing a simple runtime upgrade, and then talk about some of the more complex topics you may need to keep in mind if you're thinking about doing a forkless runtime upgrade on a live production chain. So with that in mind, I'm going to go ahead and make me a little smaller. And as you can see, we're going to start looking at some code and stuff. But before we do that, I want to quickly talk about Substrate architecture and how some of the novel design decisions that we've made allow this very unique capability of forkless runtime upgrades. So what you can see is that the Substrate client is essentially this application for running a blockchain node participating in a blockchain network. It does a lot of things. It has peer-to-peer networking capabilities, so you can communicate with the other participants in the consensus network. There's an RPC server so that users of the blockchain can communicate with it and query and update its state. We have telemetry exposed by way of an embedded Prometheus server. But really what we're going to be talking about right now is storage, and in particular, the fact that the runtime is part of storage. So the storage aspect of a blockchain represents the state that the consensus participants are coming to agreement on. So what is very unique about Substrate is that logic, the block producing logic that describes how state transitions happen, it is part of the state that the network is coming to consensus about. So it's kind of this meta idea. You see that there's also a native runtime that's compiled to the native code that runs right within the client, and that's kind of an optimization detail. But what makes Substrate really unique is this idea that the runtime is compiled to a WASM blob, and then that WASM blob becomes part of the state that the network is developing consensus around. And so it's subject to all kinds of cryptographic assurances and whatnot. And so having the ability to update this item in storage, which happens to be the block execution logic, this really important storage item, but at the end of the day, it's just a storage item nonetheless that you can update just like balances for a token or anything like that. And so what I'm going to show you over the next few minutes is very simply how to use a client that's running one native version of the runtime, and how you can have the ability to swap out this WASM runtime, expose new runtime capabilities without having to have people stop the binary that they're running, fork the chain, and start some new one. They can just do it just like they would update balances or anything like that. So not going to talk nearly as much about this slide, which is kind of how we're making the runtime. So we're more at the substrate layer as opposed to really kind of the runtime layer in this little demonstration. But the runtimes that I am using were created using Frame, which is a framework for building Substrate runtimes that can be compiled to WASM. And sort of the main thing that you should keep in mind about Frame is that you create a frame runtime by composing a number of modules, some of which Parity may provide, others you may provide on your own. You can write on your own, it's very easy, but you basically select some palettes that represent the capabilities that you need in your runtime, and you compile them, you compose them to create the runtime. And so I'll show you a little bit about that, but it's kind of an implementation detail. So the code that I'm using today is something that I prepared for this Coding Earth workshop. it's not really that important for the purposes of this demonstration what this code represents, but what you should keep in mind is I am actually currently on my computer running some V1 version of this blockchain, which you can learn all about here on GitHub. And because it's part of this workshop, of course, I add new capabilities to it. And in particular, there are new capabilities in the runtime. And you can tell that because I'm making the changes to this frame palette. A palette is what we call a module in frame. I can't remember if I already said that, but basically adding new capabilities to the runtime. And it's actually very important that I'm only adding new capabilities. You can see I've added some new storage items. I've added an event. I've added errors. And then I've added a dispatchable extrinsic that you can use to interact with all these new capabilities. But I haven't taken anything away, and I haven't changed anything that already existed. And so that's kind of one of these key elements that makes this a very simple runtime upgrade. If you're in a production chain and you're having to mutate stuff or remove stuff that already exists, the upgrade is going to involve a storage migration probably and be a little bit more complicated. But for the purposes of this runtime upgrade, basically what we're looking for is the presence of this new register name extrinsic. So here we are now on the Polkadot.js apps UI. I'm not going to spend a lot of time talking about this because I would imagine that you already know this, but you can see that the chain has been running. And yeah, let's take a quick look at VS Code where this is all running from. So I think I actually messed up the first time that I did this, and so I want to talk about that. Let's first look at the fact that this chain is running. It's been running for a while. It's this node V1. I compiled this from the workshop starting point, and then I kind of copied off the binary, and then I pulled down the more recent the changes, the workshop solution, and I compiled that. And then I actually tried to record this video once, and I'm having to do it a second time now. And what I forgot to do the first time, and this is very, very important, is I forgot to change these version numbers. I think in practice, there's obviously two different version numbers for two different reasons. And I think I only need to change the spec version. But just to be safe, I'm changing both the impl and the spec version. But this is a question that you would want to ask a little bit more carefully if you were doing a real live production upgrade. For the purposes of this demonstration, I just changed that. So basically, you can see I have this V1 binary that I copied off. This is something new. And then I made these changes to the runtime. This is on top of the changes to the palette. So this is in the lib for the runtime, and this is where we basically construct a runtime by composing all of these different palettes, including the template module. So this is where we're at right now. We have this running, and let's just go, and I'm going to do this. We're going to go off VS Code, back to Firefox. And let's go and check that if we go to template module, we don't see that new capability. It's called like register name or register nickname or something like that. So let's do the runtime upgrade now. So to do the runtime upgrade, we're going to use sudo capabilities. And we're going to do this unchecked weight variant because the WASM blob is very large. So it's going to be computationally expensive, so we have to make sure that we're able to, as the admin, as the sudo user, that's not going to cause us any problems. So now we're going to call the set code. So this is the extrinsic that's going to allow us to update that WASM blob. And let's grab our WASM blob. So we're in code, node template, and then target release W build, which I assume stands for WASM build, and then node template runtime. And if you look and you can see this was created pretty recently. So this is the one that we want. This has our new capabilities, the new register nickname, and then I bumped the spec and the info version, which is what I forgot to do before. And so now we just use this wait 0, and we're going to submit transaction, and let's see if we see this version number increase. I realize I probably should be making this larger for people. So let's see if we can see this version number increase right there. Indeed, it did. And let's go over here, and we can see that in block 562, the second extrinsic had a pseudo event. And so let's go to block 562 and learn a little bit more about that. There was this unchecked wait. We talked about that, and we updated the code, and it was successful, and we saw that in everything. So we should now be able to go and see that new extrinsic. Let's see if it exists. I believe it does. Lo and behold, we can register a name. So that's really exciting. I don't want to make this video too long. One thing that I want to touch on is the fact that we used the pseudo palette to deploy the runtime upgrade, which is not super decentralized. You probably want to have governance mechanisms around that. One of my favorite coworkers, Raul, wrote an excellent blog post about how Kusama, a network that's built on top of Substrate and uses Frame and all of these really super powerful capabilities that I was just talking about, how it's using much more powerful governance mechanisms on top of these runtime upgrade capabilities. So I'll link that in the video description, and you should read it. Super exciting, super cool. If you are using a pseudo user to deploy a runtime upgrade, as we just did, you'll probably want to schedule that for a certain block sometime in the future so that your users can be aware of it. And there's a palette for that. There's an app for that, the scheduler palette. It allows you to schedule this extrinsic at some time in the future. So that not only helps provide predictability for the users of your blockchain, but it also helps you manage the weight that we were talking about. I'm not going to get into the details of that, but it allows you to do so. Finally, the way that Kusama does things is by using a palette, and in particular, it's the democracy palette, and it involves many other interwoven palettes, and so lots more to learn there, and I hope this video is exciting for you and you want to learn more. And so if you do, please visit us on substrate.dev. We have all kinds of different resources there for you to learn more about this stuff, and definitely the community part is what's one of the most exciting parts to me. We have a newsletter to keep you updated on all this stuff. We have a really wonderful chat channel where you can come and ask questions and learn more. Weekly seminars where you can engage with other people that are learning about this. We have tags on Stack Overflow. So I hope this was exciting for you, and I hope that you're looking forward to learning more with us. Thanks for watching.